So this is example number 2 of lesson 3. Lesson 3 is talking about area scale factor. And just a quick review, area scale factor is just equivalent to the square of your linear scale factor, or from this expression here of area scale factor is equivalent to the linear scale factor squared. We can also say that we can get the linear scale factor by getting the square root of the area scale factor. So let's take this example here. The area of the province of Alberta is approximately 661,850 kilometers squared. On Marco's map, the area of Alberta is represented by 264.74 cm squared. So just from here, for any word problem solving, you need to identify the things that is given, or the things that are given in your problem. Well, this would be the actual area. Okay, and the 264.74 cm squared is the image area. Image area, or just the area in your model. And you're given the information that the scale of the map, the linear scale factor, can be written in this form here. 1:x, and we need to calculate the value of x to the nearest whole number. And if you can see here in this particular form, it doesn't contain any units. So we can say that this is in ratio form. Remember that a linear scale factor can be written in 3 different ways: by statement form, by the rate form. Rate form is more or less the same as this. However, we're talking about different units. And the ratio form, wherein you cannot see any units in your numbers, so just purely numbers. So this should be in ratio form. So if you have noticed, we're given the actual area and the image area, but we're going to solve the value of x in your linear scale factor. So based on the things that we have, we can get the area scale factor, because if you can see, we're given the image and the actual areas. So the area scale factor is just equivalent to the image area divided by the actual area. Okay, so it's just the image area over the actual area. So if I'm going to substitute the values, this will give me 264.74 cm squared all over the actual area, which is 661,850 kilometer squared. So this would be your area scale factor. Well, this particular value here is okay. It gives you the area scale factor. That means that for every 264.74 square centimeters in your model, it would represent 661,850 kilometers in the actual area of Alberta. However, we can rewrite this in such a way that we can reduce the numbers. And we can do that by dividing both the numerator and the denominator by 264.74. Okay, so I'll be dividing both of the numerator and denominator by 264.74. This won't affect the value uh, of the whole thing, because anyway, I'm just dividing it by essentially 1. Remember, 264.74 divided by 264.74 is just equal to 1. If you can remember in your Math 8, this is just a way of reducing your fraction. So in a way, you're just doing reduction of your numerator and denominator. So therefore, the area scale factor can also be written as 1 cm squared. So because 264.74 divided by 264.74, that just gives you 1 cm squared, all over 2,500 kilometer squared. So this would be the area scale factor. However, we want to get the linear scale factor in ratio form. So to solve for the linear scale factor, we can use the above expression that the linear scale factor is just the square root of your area scale factor. So therefore, I'm just going to square root the values that, or the value that I get from your area scale factor. That is 1 cm squared all over 2,500 kilometers squared. So remember that the square root here is for both numerator and denominator. So I would get LSF, or the linear scale factor. Square root of 1 is just 1. Square root of cm squared is cm. All over 2,500, if I'm going to take the square root, that gives me 50. And then square root of km squared is just kilometer. So the linear scale factor is given by 1 centimeter for every 50 kilometers, or I can write this one in the rate form of 1 cm is to 50 kilometer. Okay, so this would be the linear scale factor in rate form. So this is the rate form. However, I want to get the value of the linear scale factor in ratio form. So how would I do that? So how would I actually get the value of the ratio form? Well, if you have noticed in the ratio form, we can get the ratio form if we have both units in the numerator and the denominator that are equivalent. So therefore, we want to convert our cm to kilometer, or our kilometer to centimeters. Well, again, I want to convert my kilometer to centimeters. Well, 50 kilometers to centimeters is just 1 kilometer is 100,000 centimeters. So 1 kilometer is 100,000 centimeters. So if I gonna multiply that one to 50, that gives me 5 million. So if you can see here, if I have cm over cm, that cancels out. So that would leave me an LSF of 1 over 5 million, or it can be written in ratio form as 1 is to 5 million. So if you can see here, this is just the value of x. So x is just equivalent to 5 million. So therefore, x is equal to 5 million. So that would be the value of your x. Okay, so that's how you answer your letter A question. So if you know the area scale factor, it also follows that you know the linear scale factor. So let's take the second question here. On the same map, the area of the province of British Columbia is represented by 376.839 centimeters. Determine the actual area of the British Columbia to the nearest 100 square kilometers. So nearest 100 square kilometers. So if you can see here, we're given this value, and this particular value is actually from the model or the image. Okay, and the question mark is the actual. So this is your question mark here. So what do we have? Well, we want to get the actual area. So again, if I'm gonna list out the things that I know that the area scale factor from the first from my previous from letter A, it's 1 cm squared for every 2,500 kilometers squared, right? And then I've given the image is equivalent to 376.839 cm squared, and the actual is the question mark. Okay, so how would I get the actual area? So I can solve this one using proportional reasoning. So I'm gonna use proportional reasoning. So that means that I'm gonna write that 1 centimeter squared all over 2,500 kilometers squared. So this is the image and then the actual. So in this particular case, we're trying to get the actual. So this is the question mark, the actual, and we know the value of our image. So 376.839 cm squared. Okay. So how do we solve for x here? So we're just gonna cross multiply. So x is equal to 376.839 cm squared all over times 2,500 kilometers squared. That would be all over 1 cm squared. So if you can see here, I can cancel out the cm squared. So what is left is the unit for kilometers squared, which is the one that we wanted, the actual. So you use your calculator in calculating for that, and try to take note that it should be to the nearest 100 square kilometers. So that would be 376.839 multiplied by 2,500. So that gives me around 942, so 942,000 and 97.5, or the nearest 100 kilometers. So approximately that is 942,100 square kilometers. So this would be the area of British Columbia. So this is the actual area of your of British Columbia.